you should have a good grasp of the capabilities of the machine and what you can safely do with it. Before we go any further into the process, let's review some basic information. Manual. If you have not read the manual yet, please stop the video and do so now. Okay, now that you've read the manual, you should be familiar with the safety information in Section 1. Also, it would be a good idea to review your company's safety policies and local regulations before proceeding further. To be sure you understand the importance of this safety information, let's review it again. You should, at a minimum, always wear safety glasses, earplugs, and safety shoes when operating this machine. Rotating machinery is inherently dangerous. Remember to keep clear of the machine at all times. Never wear loose-fitting clothing, jewelry, or loose long hair near the machine. Never lean or reach in to adjust the machine or remove chips while the machine is rotating. Remember to disconnect the machine from its power source or lock it out before doing any setup procedures or adjustments. Also, you should make sure all cords and hoses are kept away from moving parts of the machine during operation, so you won't become entangled in them and injured. Make sure to read the electrical specifications on the hydraulic power unit or the electric drive motor and match the power requirements with the electrical power source. Also, make sure the electrical power is properly grounded to prevent electrical shock. This machine is not intended for use in potentially explosive environments and should not be used under those conditions. The pressure relief valve on the hydraulic power unit pump should not be adjusted. It is factory set to the correct pressure to avoid damage to the system. Always make sure you have securely fastened the machine to the workpiece before beginning any boring operations. And make sure you have adequate lighting in the work area. Many of these safety warnings are on a warning label found on the Model BB 1149 rotational drive. Make sure you locate this warning label and review it each time you set up and operate the machine. Most safety measures are just a matter of common sense. So, use your head. Don't do anything that will put you or your coworkers in jeopardy. In this section, you will become familiar with the components of the Model BB 1149 portable boring bar. The rotational drive is a compact unit with a 4-to-1 worm gear reduction and sealed lubrication that can be mounted anywhere along the bar. An internal key inside the collet drives the bar. The clamping ring mounts the rotational drive to the spherical bearing mount with one bolt. Safety detent pins keep the unit from accidentally rotating on the spherical bearing during the mounting process. A clamp collar provides a snug slip fit on the bar. There is a threaded socket to accept the end of the feed screw. The motor mount accepts hydraulic, electric, or pneumatic motors interchangeably. The axial feed unit can also be positioned anywhere along the bar and is attached with 2 clamping collars. Since the unit is clamped to the bar, it must move with it, so clearance must be allowed. The feed screw threads through the unit with one end either in the socket on the rotational drive, or if the unit is away from the rotational drive, the end of the feed screw can be locked in the tack weld block accessory. You may want to weld a flange onto the block for clamping rather than welding as shown here. Automatic feed stops clamp to the feed screw and shut off the feed when they depress the disengagement pin during the movement of the feed unit with the bar. Forward and reverse feeds are engaged simply by pushing the feed shaft into the body until the pin drops into the engagement slot. An arrow on the unit shows which way the machine will travel when the feed is engaged on that side. When engaged, the unit can only be moved in the feed direction with the hand crank. Neutral is with the feed shaft centered in the middle. In neutral, the bar can be cranked by hand in either direction. Feed rate is set with 2 feed rate knobs on either end of the unit. One is forward, the other reverse. Screwing the knob counterclockwise away from the body of the unit increases the feed rate. Feed screws are available with 12 inches to 36 inches of travel and must have one end fixed so it will not rotate. 3 boring head sets are available. 2 sets accept half-inch square, high-speed steel, or brazed carbide tool bits. The smaller set contains 5 boring heads to cover a diameter range 4.5 inches to 12 inches. The larger set has a single hub and 2 sets of tool arms that cover the 12-inch to 24-inch diameter range. Both sets of boring heads have split bodies, allowing you to clamp them anywhere along the bar. The third set features cartridge boring heads for diameters from 5.96 inches to 12.75 inches. Each boring head consists of an adjustable tool mounting block, a carbide cartridge tool holder, and a carbide boring head cartridge. These tool holders are not split and must be slipped onto the end of the bar. For smaller diameters, you can use a bar with in-bar tool holders and bore as small as 2.5 inches in diameter. You can order the bar with the tool holes already in it, or purchase a drill guide kit and install them yourself. We will show you how to use the drill guide kit later. Standard model BB1149 boring bars are 2.25 inches in diameter with a full-length keyway. Bars are available in lengths from 24 inches to 12 feet. Also, 1.25-inch diameter bars can be used in the machine with the small bore adapter kit to bore as small as 1.375-inch diameters. Spherical bearing mounting brackets are available in either single or double arm configurations. Tack weld plates provide standoff spacing and easy attachment to the workpiece. Drive power is either electric, pneumatic, or hydraulic. A range of hydraulic motors is available from 2.2 cubic inch displacement and 148 bar RPM to 8.9 cubic inch displacement and 36 bar RPM. Hydraulic power units are electrically driven with piston pumps producing a 6-gallon per minute flow. Various electrical configurations are available. For those who need to operate the boring bar from a generator, we recommend the electric power assembly. This assembly uses a 1.6 horsepower series wound universal motor available in 120 volt 20 amp or 230 volt 11.5 amp configurations. Or you can use the 5 horsepower single phase hydraulic power unit. This unit features an induction TFEC motor that is available in 230 volt 60 Hz or 220 volt 50 Hz models. Your generator supplier can help you obtain the generator that is properly sized for your application. This machine is not certified for use in potentially explosive environments. It is the customer's responsibility to avoid potentially hazardous conditions when using this machine. The fire hazard may be reduced by using one of the 2 3-horsepower pneumatic motors available. One air motor produces 120 bar RPM with 115 foot-pounds of torque at the bar, while the other produces 57 bar RPM and 234 foot-pounds of torque. Other accessories available for use with the model BB1149 portable boring bar will be described later. The first step in setting up the model BB1149 portable boring bar is to place the proper length bar in the bore and get it centered. There are instructions for determining proper bar length in section 5 of the manual. Centering the bar in smaller bores is probably easiest to do with the setup cones. With the bar resting in the bores, a setup cone is slipped onto each end with the dowel pin in the keyway and forced into the bore using the clamping ring jacking screw. This can be done by one person as shown here, but it is often easier with a second person who can hold the bar in the bore on one side while the other side is being clamped, especially with the longer, heavier bars. With the centering cones clamped with their set screws, the clamping collars can be removed. When the bar is centered, the next step is to attach the tack weld plates to the mounting brackets, making sure the bolts are centered in the oversized holes. Also, make sure the spherical bearing is centered in the oversized hole of the mounting bracket, so you will have room for centering adjustments if needed later. Now the mounting bracket and tack weld plate can be slipped onto the bar, up against the workpiece and the position marked. Any paint or rust should be removed before you begin welding. Now, using safe welding techniques, tack weld the mounts securely to the workpiece. 4 good welds will be sufficient for most boring jobs. The bracket can be mounted up to 5 degrees out of perpendicular alignment and still function properly because of the spherical bearing design. The setup cones or centering donuts can now be removed. After rough centering is finished, you can fine-tune the centering even further by loosening the bearing mount bolts and adjusting the bracket set screws until precise centering is obtained using a magnetic-based dial indicator attached to a tool bit in the bar, as shown here, or to the tool head in larger bores. Remember to retighten the bearing mount bolts. The hydraulic motor is attached to the rotational drive. In this sequence, we will be using the 2.2 cubic inch 148 RPM motor. It is attached with just 2 bolts. Next, the rotational drive unit is slipped onto the bar, taking care to line up the internal key with the keyway in the bar. Push it firmly onto the spherical bearing mount and rotate it slightly until the safety detent pin drops into place. Tightening the single bolt on the main clamp collar locks the rotational drive in place. Snug up the bar clamp on the rear of the rotational drive until there is some resistance, but the bar will still slide through it freely. The next step is to thread the feed screws through the axial feed unit with the feed stops and the jam nut positioned appropriately. The axial feed unit slides onto the bar, and the feed screw is threaded into the rotational drive unit. Tightening the feed screw jam nut and the 2 clamping collars completes the installation of the axial feed unit. You can mount the axial feed unit anywhere on the bar, as long as you have a place to attach the threaded tack weld block. Since much of the control of the BB1149 is done with the axial feed unit, it is best to place it where you have good access to it during the boring process. At this point, you need to hook up the hydraulic hoses from the hydraulic power unit to the motor. Plug the power unit into a properly grounded receptacle rated for the correct phase, amperage, and voltage output. If you are using a 3-phase power unit, you will need to check the phase rotation of the power unit motor. This is done by removing the inspection plate and jogging the motor to check the rotation. Before jogging, make sure the hoses are connected to the hydraulic motor or the flow control is turned completely off. This will prevent any damage to the hydraulic unit. If the rotation is incorrect, your electrician will need to switch 2 of the 3 wires in the power cord plug. Re-inspect to make sure rotation is correct before reattaching the inspection plate. After checking to make sure there are no rotational obstructions, turn on the power unit to check for proper bar rotation. If the rotation is incorrect, switch the hydraulic hoses to reverse it. Now you can jog the bar into position to install a properly ground tool bit. Place the 3/8 inch square high-speed steel tool bit into the in-bar tool holder positioned for proper rotation, feed direction, and depth of cut. Each revolution of the screw in the bottom of the tool holder pushes the tool bit up 50/1000ths of an inch. So, since we turned the Allen wrench one full turn, we have set a 50/1000th inch deep cut for this demonstration. The machine is now set up and ready to bore. Under normal conditions, using setup cones, an experienced operator should be able to complete a setup like this in 30 minutes or less. Before you start up the machine, you should make sure the axial feed unit is in the neutral position. After checking to be sure the area is clear so the machine can be safely operated, the hydraulic power unit is turned on, starting the bar rotation. The rotational RPM is adjusted with the control valve on the power unit until the proper rotational speed is obtained. You should set the rotational speed in relation to the diameter being bored, the material being cut, the depth of cut being taken, and the type of tool bit you are using. We are using a high-speed steel tool, so we want the RPM to be in the slower range. Now you can manually advance the bar until the tool bit just begins cutting. The next step is to engage the feed. The arrows on the axial feed unit will show you which side to use. The feed is engaged by pushing the shaft in until the pin drops into the detent slots. As the machine begins cutting, you can adjust the feed rate as necessary. Screwing the knob counterclockwise will increase the feed rate. Feed rates vary from 0, with the knob screwed all the way in, to 19/1000ths inch per revolution, with the knob screwed out about 5/8 of an inch. During the boring operation, you can disengage the feed by bumping the shaft into the neutral position. You can then crank the tool bit back out of the bore. Next, we will demonstrate how to use the automatic feed stop. We will bore 1 inch into the hole. With the feed rate set where you want it, make sure the cutter is away from the bore. Position a feed stop just in front of the feed stop pin and let the machine advance until it quits feeding forward. Turn off the machine and measure the distance between the face of the knob and the feed stop. In our demonstration, it's 1/2 inch. Next, we will position the tool bit at the beginning of the bore as a 0 reference. Since we want to bore in 1 inch, we measure 1 inch from the feed rate knob face, add 1/2 inch to account for pin backlash, and set the feed stop at that point. We will also mark the bar 1 inch from the rotational drive to check on our accuracy. After turning on the machine and engaging the feed, boring will begin. Travel 1 inch and automatically stop the feed. The feed is shifted to neutral and the tool is cranked back out of the bore. The automatic feed stop is a useful feature if you need to bore up to a shoulder in a small diameter bore where visual inspection is impossible. When the feed stops are not being used, they can be swiveled out of the way. Now we will demonstrate cutting with a brazed carbide cutter in the bar. We will set the depth of cut by eye and lock the tool in place. You will want to use the higher RPM motors for best performance. The 2.2 cubic inch motor we have installed will produce a maximum 148 RPM at the bar. Manually move the cutter forward until it just contacts the workpiece and engage the feed. The feed can be adjusted during the boring process. The hydraulic power unit flow control is adjusted into the higher RPM range. When the boring pass is finished, it is important to shift the feed unit into neutral and let the tool make at least one full rotation before you shut off the power unit. It is easy to break the tip off of a carbide tool bit if the machine is shut off while the tool bit is in a cut. In the next sequence, we will demonstrate how to accurately set the depth of cut and make a heavier boring pass in A36 steel using a high-speed steel tool bit. For good performance in a heavy cut, it is best to use the higher displacement motor. So in this demonstration, the 2.2 cubic inch motor is replaced with the 8.9 cubic inch motor. This will restrict the bar rotation to a maximum 36 RPM. We will start with the tip of the tool just touching the inside of the bore as a zero reference. The cutter is backed out of the bore, and the distance from the tip of the cutter to the bar is measured. In this case, it's 210 thousandths of an inch. Now we will add 250 thousandths to the measurement and move the cutter out to that combined dimension. The screw in the bottom of the tool holder can be used to push out the tool bit. After locking the tool in place, we are ready to make a 250 thousandths deep cut. We will start the cut with a slow feed rate and increase it as the boring progresses to demonstrate the metal removal capabilities of the machine. At the maximum feed rate, we can remove about 3 cubic inches of material per minute. Three main factors determine how deep a cut you can make with the model BB1149. 1. Bar support. The bearing mount should be rigidly attached as close as possible to the bore. 2. The diameter of the bore. The larger the diameter, the lighter the cut must be. 3. The type of material being cut. The harder, tougher materials require a lighter cut. Getting the most out of your model BB1149 is a matter of common sense and good general machining practices, such as always using a sharp tool bit, adjusting the RPM to match the diameter you are cutting, and the type of cutter you are using. If you need to use the electric drive motor rather than the hydraulic, they are easily interchangeable. It just takes a few minutes to switch from one to the other. First, remove the 2 hydraulic motor mounting bolts and remove the motor from the rotational drive. Align the key on the electric motor drive shaft with the keyway in the rotational drive. Slip it in place and tighten the mounting bolts. The electric motor has 2 speeds and can be used with either high-speed steel or carbide tool bits. Here we show the BB1149 with the electric motor in the slower speed, cutting with a high-speed steel tool bit. At this setting, the motor provides 88 free-speed RPM at the bar. And here, the motor is in the higher 168 RPM free speed range, cutting with a carbide tool bit. The electric motor drive is ideal where you need to run the machine off of a generator in the field, or where you need intermittent high torque for hard spots or an interrupted cut. With the electric drive, the BB1149 will deliver over 400 foot-pounds of intermittent torque during boring operations. If you are concerned about fire hazard, you may want to use the 3 horsepower pneumatic drive option. A low-speed 57 free-speed bar RPM model and a higher 120 free-speed bar RPM model are available. Mounting is just as easy as the other motors. A muffler system keeps the noise level, inherent to any large pneumatic motors, in an acceptable range. Earplugs, of course, are still necessary to protect against hearing loss. Up to now, we have shown all boring operations at smaller diameters for ease of demonstration. In the next sequence, we will demonstrate the use of the boring heads for larger diameters. The 4.5-inch to 12-inch diameter boring head set has 5 tool heads to span the range. In this demonstration, we will use the largest tool head of this set to bore a hole that is 11.5 inches in diameter. All the tool heads are split, so they can be mounted anywhere on the bar. The tool head is simply clamped onto the bar at the most convenient place. A tool bit is clamped into the tool holder slot and adjusted for depth of cut as demonstrated previously. The boring process is the same as with smaller diameters, except the rotational speed should be slowed to prevent the cutter from rotating too fast. Boring diameters between 12 and 24 inches require the use of the largest tool head. This head features a split hub to which the 2 arms are attached in the proper position for the diameter being bored. Here we are boring a 19-inch diameter hole with the largest tool arms. Cartridge boring heads are available for boring 5.96-inch to 12.75-inch diameter holes. Each boring head consists of a tool mounting block, a cartridge tool holder, and a carbide insert boring head cartridge. These tool holders are useful when doing precision boring using the micro adjust feature, where deep cuts are not necessary. If you need to bore in the 2.5 to 4.5 inch diameter range, you will need to have tool sleeves in the bar. You can either buy the bar with the tool sleeves installed or install them yourself. The drill guide set provides the drill jig, drill bits, reamer, and taps needed to install tool sleeves in the bar. With the drill jig clamped in position on the bar with the smaller hole over the keyway, the 2 holes are drilled. The larger hole is drilled all the way through the bar, and the smaller hole is drilled halfway through the bar. After reaming the larger hole and tapping the smaller hole, the tool sleeve can be installed. This way you can install the tool sleeve wherever you need them on the bar. A smaller set is also available for the 1.25-inch diameter boring bar. Instructions for this process are described in Section 5 of the Operator's Manual. Facing with the new and improved facing head accessory is easy to do. Since it is a split design, the facing head can be placed anywhere along the bar. The unit will face from 2.5 inches out to 18 inches in diameter. Compact yet rigid, the model BB1149 facing head needs only about 5 inches of axial clearance. The unit is assembled on the bar by fitting the 2 halves of the body over the bar, taking care to align the key in the keyway. Four bolts attach the unit rigidly to the bar. The tool head can be attached to the 1-inch lead screws like this, so you can face down to 2.5 inches in diameter, or the reverse if you need to reach the maximum 18-inch diameter. Either high-speed steel or carbide cutters can be used depending on the diameter being faced and the type of material you are cutting. Make sure the cutter does not protrude from the back of the tool holder or it will catch on the actuator arm. Dual cam-actuated pins on the feed actuator arm allow you to engage, disengage, and reverse the feed during facing operations merely by twisting the end of the handle. The feed actuator arm is attached to the bar so that the actuator pins will contact the star feed wheel. A split clamp is fastened to the bar to hold the actuator arm in place against the facing unit. Depth of cut is set by carefully advancing the bar with the hand crank on the axial feed unit. After checking to be sure the area is clear, the power can be turned on to begin the facing. To engage the feed mechanism so the unit will feed away from the bar with the tool head on this end of the feed screws, the feed actuator handle must be twisted clockwise. By turning over the tool head, you can continue facing within a confined space. When the facing is finished, the feed is disengaged, the machine allowed to rotate a couple more times, and the power shut off. The tool head can be retracted with a speed wrench or electric drill, driving the star feed wheel. The small bore kit allows you to bore holes as small as 1.5 inches in diameter using a 1.25 inch diameter boring bar. Sleeves are slipped into the rotational drive, axial feed, and spherical bearings. When inserting the sleeve into the rotational drive, the split end must be directed away from the spherical bearing. Clips on either end keep the sleeve in place. With the 1.25 inch diameter bar, you can extend the versatility of the model BB1149 portable boring bar to these smaller boring jobs. You must be sure to very securely tighten the clamp collars on the axial feed to ensure a good grip on the bar. When boring with the small boring head, multiple holes may be bored exactly the same diameter by moving the tool head from one to the other with the tool bit left in the same position. The Model 306P automatic bore welder can be used with the Model BB1149 portable boring bar for welding up bores prior to boring them out to original dimensions. An interface kit is available to mount the bore welder right on the same spherical bearing mounts. So, once you have centered the boring bar, the bore welder will also be aligned. After cleaning out the bore with the boring bar, the rotational drive and the axial feed units are removed. Now, the bore welder interface ring and mounting rod are clamped on the spherical mount. Place the ring with the rod on top in the 12 o'clock position and align it with the special alignment gauge. Clamp the ring lightly. Over-tightening will make it difficult to remove the bearing. Next, the bar is removed, and the bearings are removed with the special bearing removal tool. Now the clamp collar can be securely tightened. Following the bore welder manual, all the electrical, shielding gas, and wire feed connections are made. The bore welder unit with the proper extension tubes and welding tip is slipped onto the mounting rod and the head is positioned roughly at the center of the bore. With the rotate jog button on the control box, the bore welder is rotated until the tip of the nozzle is in a horizontal position at either 3 o'clock or 9 o'clock. A mental note is made of the gap between the nozzle and bore, and then the nozzle is rotated to the opposite side and the gap checked there. Now the large thumb wheel clamp is loosened and the bore welder is pivoted half the gap difference between the two sides. Repeat this process until the gap is equal at the 3 o'clock and 9 o'clock positions. Next, the offset head is adjusted for bore size. The nozzle is rotated to the 12 o'clock or 6 o'clock position, and the gap is adjusted with the offset head thumb wheel to 1/8 inch or less. The nozzle is rotated to recheck the gap all around the bore, and any final adjustments are made to make sure the gap is correct. And then advance the nozzle to the opposite side of the hole. Now the power settings are made on the control box and the power unit according to the manual. Next, the ground lead is securely attached. The bore welder is rotated to the step position by holding down the rotation initiate button until rotation stops. The wire feed button is held down until approximately 18 inches of wire is fed out the end of the nozzle. The excess wire is trimmed with wire cutters. The shielding gas conduit is purged by depressing the purge button for 15 seconds. And the welding is started. The bore welder automatically lays down a circle of weldment as it travels stepwise through the bore. Multiple layers of weldment may be applied to the bore if necessary to reduce the ID to slightly less than the final diameter desired. When the welding is finished, the bore welder is removed and the boring bar reassembled in the bore. Boring of welded-up bores is best done with a carbide tool bit. Setup and operation of the boring bar is the same as we have already demonstrated, except you should remember to take a sufficiently deep cut on the first boring pass to get beneath the hardened surface of the welded material. Normally, you can make a rough cut between 60 thousandths and 120 thousandths deep to remove excess material, and then make a finer finish cut in the 15 thousandths to 30 thousandths range to bore out the hole to the final diameter desired. With a special short bar that can hold straight shank or number 5 Morse taper spade drills and the heavy-duty drilling accessory, you can use the model BB 1149 portable boring bar to drill large diameter holes. The machine produces plenty of torque to bore holes in the 1.5 inch to 3 inch diameter range. Tree panning assemblies are available to cut discs from the side of vessels or other structures. A variable diameter tree panning tool